this is KP, the Math G here. We're looking at the big three in AP Calculus, and the big three are the limit, derivative, and the definite interval. And we might have an indefinite interval called the antiderivative, and then of course with that is the integration. Have a problem up here, and it is a piecewise function, and what we want to look at is, and I erased it, but we want to see if G is continuous. Alright, so G, I know it has three of these, doesn't it? But you can do that on a piecewise function. Okay? This is linear, this is a constant, and this is a parabola. Now there are three rules. And let me get a different color. Let's see, I think I have green somewhere. Well, I ain't gonna worry about it if I don't. Let's get a different color. Let's get red or black. Let's look at our three rules. And by the way, this is our my 201st YouTube video. After I do 203 of them, that will be actually 200 YouTube videos in calculus. I did 2 of them to apply for a job, and 1 of them I introduced my wife, who allows me to do all this. Well, I do it anyway. She lets me though. But anyway, 3 rules. We're looking at continuity. Is something continuous? You might have a graph. When I talk about continuity, let's say we got this curve here, alright, and we got this line that comes through somewhere, and it's kind of going out like this, and there's a point somewhere, alright. Is this continuous? This is continuous, but is this continuous? Okay, this is a piecewise function. So what we need to do, we had 2 lessons on, well, this will be the second of 2 from this viewpoint here. But I've had 2 other lessons on continuity. One was graphical and one was algebraic, as we're doing here. I'm doing another algebraic one, and there's going to be a reason why, and I'll talk about that in just a moment. But let's look at rules for continuity. Number 1, and we talked about it before, so you can look at the previous videos and see, but let's go ahead and look at it again. G at, now we're looking at 3, right? Does G at 3 exist? Is there a number for that? Well, let's look at that. Now, when I say G at 3, I don't want something less than or greater than 3. I want something that's equal to 3. So G at 3 equals what? Well, it goes back to 5, doesn't it? Now, yes, it does. So we can erase the question mark. It does exist. G at 3 equals 5. Alright, that's the first thing. Yes, it does exist. Okay, so we put a check by that. What that simply means, boys and girls, ladies and gentlemen, is that at 3, we we go up to 5, and there's a point there. Now, we're looking at continuity at 3. So this parabola and this straight line needs to connect at 5. If it connects, say, somewhere else, like this, and then goes on from here, like that, that's not right. There's no continuity here. This is probably going to be an open circle right here. Okay, so that won't work. Okay, and I apologize for my, I need to get some more markers. My markers are getting weak. Alright, but the first rule is G at 3 equals 5. Okay, the second rule is, does the limit exist? Oh man, that's writing terrible. It's horrible. That's horrible. Let's try it for this one. Does the limit as x approaches 3, g at x, does it equal, well, we hope that it not only does it exist, but since we found 5 the first time, we need to find 5 all the time here. Let's put a question mark by that. If this had failed, and say, well, I don't see anything for that, then we stop and we say that F is not continuous, that F equals 3. Since this is true, that we have a definite number that it goes to, yeah, G at 3 equals 5. We got to check the limit now. We got to go to number 2. Now we got to check the limit from the left. That's going to be the negative after the 3. And if we're checking the limit from the right, that's going to be a plus after the 3. Not negative, not positive. From the left is a minus sign after the 3. And from the right is a plus sign after the 3. What that means is, ladies and gentlemen, is this. If there is, well, these things write terribly. I'm going to throw that one in there. Pretty soon I won't have any markers. Anyway, if something's coming here, right there, alright, we look at the limit from the left, and hopefully that's 5. Okay, that this is, the y value is 5. And then when we look at it from the right, maybe we're looking at something like this. Okay? And if we look at it from this way, coming this way, we better come to 5. This limit from the left, we're looking at all of this. And that's what we're saying. First of all, does this exist? Is there a point here? Yes. Second of all, do these limits reach this same point? This same y value? That's what we're looking for. Alright, well, let's see. Now, it's got to work on both the left and the right. Otherwise, the limit does not exist. So let's look at this. This less than means the limit from the left. This greater than is the limit from the right. Always look for a less than and a greater than to do your left and right limits. This is a piecewise function, so we got to try everything. We can't just pick one and try just that and leave this one out. We can't pick this one and leave this one out. This is the limit from the left side, so let's look at it. Put number 2. The limit as x approaches 3 from the left. 4x equals the limit as x approaches 3 from the left. 4 times 3, yeah, 4 times 3 minus 5. It's looking kind of bleak, isn't it? Because isn't this the limit as x approaches 3 from the left? This is 7. This is 12 minus 5, which is 7, and that limit's equal to 7. Well, from the left, this limit equals 7. Doesn't it? We can stop. No continuity. Even though, now watch this. Well, KP to math G, look at this next limit on the right. Alright, let's do that. You may be coming up with something here. Hold on. Maybe we should have checked the right first, and then that's kind of what I wanted to do, but anyway, it don't matter. 2x. 2x. Limit 3 from the right, because it's greater than. Now let's see, let's plug it in. 3 squared minus 2 times 3 plus 4. 9 minus 6 plus 4. Well, you know. Let's see, I do think we got the same number here, don't we? 9 minus 6 is 3. 3 plus 4 is 7. So, from the right, it's also 7. So the limit from the left is 7. And the limit from the right, wouldn't you know, is also equal to 7. So the limit exists. Alright. Go make an argument, but okay. No, I know. So if this is the same, then what we say about the limit without the plus or negative sign, we just simply put a 3 here. Yes, it exists. So we have g at 3 is equal to 5, and the limit exists. So the limit does exist. Check. Remember I said stop a while ago, didn't I? Right? I said stop. Because number 3 says that, oh, I keep wanting to say alpha at something. G at 3 has to equal the limit as x approaches 3, g at x. Well, what's this one? It's 5. What's this one? I'll put a question mark over this. Alright. This is 7. That does not equal, 5 does not equal 7. Never has, never will. Now what do we say about this continuity? It's broken up, isn't it? This number 1 has to fit number 2. Now had this one been 7, had I changed this to 7, We got it. Yes. Yes. 7 equals 7. And what you got to say is, G is continuous at, you would say, G is continuous at x equals 3. That's what you got to conclude. But this is not a 7. 5. In this case, G is not. G is not continuous at x equals 3. That's the conclusion you need to make. When you're dealing with this, you have this say on a free response question, you've got to be able to say, one, this is 5, and this is 7. So we got the first two working for us. Yes, this exists. Yes, the limit exists, but they're different. This one is 5. This one is 7. Here again, what I'm saying to you. If there's nothing out here, then this does not exist and we can stop right away. I'm looking for a stopping point. If once I got here, this is where I was to stop. You don't really have to do the limit does exist. Well, so what? This doesn't match. Okay? Now you might want to go on and say the limit does exist at the same number. These could be different. The limit may not exist. This could exist in the limit. This could be an 8 maybe. What if that had been 8? Now you don't have a limit. Understand? The limit does not exist. So you cannot even, because the limit does not exist, you don't even do this. Because the limit doesn't exist. You don't even do number 3. D is not continuous at x equals 3. But even though the limit does exist, even though these two numbers must match, they don't match. G at 3 is not equal to the limit here. Therefore, G is not continuous at x equals 3. From our last video, everything matched. So F in that case, F was the function. So F, it was continuous. I want to say at x equals 2 or something like that. But here, in dealing with the big 3, we need to really get continuity nailed down. Okay? Now that is what that means. Now we're gonna get into this is it for limit. So this will be one of the big 3. Actually, this is about, I want to say, the 1, 2, 3. This is the 4th lesson on talking about the big 3. So we're done with limit. I could show more on limit if I wanted to, but we're done on limit. Anything else you can find out? I've got videos on everything. You might just have to Google it and type it in, but it's there. Excuse me. I always have this early in the morning where I can barely talk, but that's it. Alright, well, I'm getting ready to go to the Y. I need to work this belly down. You see that? I know I see it in the mirror and I hate what I see. But I am taking some, trying to eat less. I gotta eat smarter. I love bread and I love ice cream, period. And that's what's putting this stuff on. But I do exercise. If it weren't for that, oh, I'd probably be stuck way out here. But needless to say, the big three in AP Calculus, what we're looking at. Ladies and gentlemen, I trust this has helped you understand what constitutes continuity. 3 rules. Keep that in mind. Anyway, if you have not subscribed, please do so. If you'd like to make a comment, please do so. Please, at all, if anything, hit that like button. Put a smile on my face. But if you don't do any of that, it's not for my glory. Now, I'm not looking for credit here. I'm not looking to make money off of this. Although that would sound pretty good, wouldn't it? But I'm not here to make money. I'm just here to help you. This is for your benefit right here. And so the best thing that I get out of it, I keep my mind sharp in AP Calculus and in any other math that I do. But anyway, I'm here for you to help you out. And if you're getting ready to take this AP Calculus class, you are already getting a head start right now. Just saying, you're getting a head start. So when you get in with your classmates, you can get your classmates up to speed because you're already up to speed. Alright, having said all that, KP the Math G signing off. Ladies and gentlemen, have a great, great day.